Hi everybody, my name is Adrian Peret. I'm working for Nokia as a Chief Architect Cloud, and during the presentation I will cover the evolution to cloud native, focused on why and how to do it. Before we start, few words about myself. I like K-diving. I do it as much as I can, but for sure less that I would like to do it. For a little bit of clarity, I am the one in the red suit in the left, and that is a dry suit, a very different kind of suit that the word actually usually describes. This picture were taken few years back, meanwhile diving Ojamo mine, that is a flooded mine located in Finland in the city of Lohja. As it was like now, well, very close to Halloween. Actually, we are a little bit now after it. We felt that carrying a pumpkin inside the flooded mine is a very good idea, and then somehow we also managed to light a candle inside the pumpkin, even that there is water everywhere. So of course it wasn't really a candle. It is an underwater light that is stuck in the back of the pumpkin. The smaller picture are from the same place, but showing our lazy way of going around the mine tunnels and galleries by using an underwater electrical scooter. So for those more claustrophobic, now it's time to look outside the window, as on the bottom small left corner picture is me passing through a restriction that is a very small passage, basically squeezing through a hole in a rock in the way out. So what is the connection with the today presentation? Well, not much, just a warm-up. So now more about me, but a little bit closer to the subject. So I'm an engineer by profession. I started as a product expert for the Nokia Web Gateway that was part of value-added service solutions, and wondering what kind of expert I could be in day one on my job when I'm looking at a product that I never heard of, seen it before. But yeah, well, whatever, Nokia considered me fit for that. So some of you that are as young as me, you may wonder what WAP is it. So WAP is actually a name of a protocol. Sorry, it's a protocol, and the VML, it's the language, which is a wireless markup language that was the first method to access the net that time. So this was around 2000, because devices were very limited in computing, memory, and display, and that the networks were able to transmit very limited amount of data in those times. A new language required to be invented because HTML, believe it or not, was far too heavy. Finished that position 6 years later as a senior engineer. After living in Finland, sure, what next country to move will be best? Well, Saudi Arabia. From a very cold and humid environment in Finland to a very hot and dry environment in Saudi Arabia. There I've been leading a team of support engineers for first and second line of support and emergency for value-added services products in that area. Then moved back to Finland as a senior specialist, value-added services technical architect for a hosting service line. And that time this was a very early concept of a SaaS model, basically a network as a service, which Nokia built data centers in Vienna for European customers and Singapore for Asian customers, from where we provided value-added services as a service for various customers. It was a very cool challenge because it was very forward-looking concept and also required to put together components that were never built for such a concept. I was located in Finland, the project base was in Austria. The second half of the project was in India, and several systems were running out of Singapore, Netherlands, Finland, and Austria. And that means basically Monday to Friday flying either to Vienna or Singapore or other locations to be able to make all this puzzle to work. Moved then to many services, which is part of global services as a chief architect, where I've been taking care of the architecture, design, and implementation of the service operations center tools and connectivity for the many services global. And that covered anything from data centers, build up, workforce management, connectivity, data warehouse, ticketing systems, and so on, with global delivery centers located around the world, some of them in Chennai, India, Noida, India, Amadora, Portugal, and so on, Sao Paulo, Brazil. For a short time, moved as a chief architect remote access solution, where I focused on connectivity, data security, and automation, and virtualization of the solution at that time. And then ended up in the current position where I'm now for 6 years or so, where I'm handling the Nokia Telco IT cloud architecture, long-term vision and strategy covering the telco IT domain, cloud native, cloud infrastructure, edge cloud, API harmonization, cloud radio access network. So basically, you can see that I'm a very curious mouse, always going around, checking everything, questioning everything. Sure, you get eaten by the cat now and then, but that is a risk worth taking. Learning more in very different areas can be found very useful in very unexpected domains. So curiosity is keeping me going. Going into unknown territory is actually very rewarding. This can be seen from even from my career path, where I always try to move around in a place where I know least, basically where I'm the most stupid guy in the room, because then there is a lot to learn, a lot to think, a lot of dots to be connected, and basically there is no limit. Let's start by talking about system theory first. Now a little bit more in the subject. So if we group the system based on the certainty of the outcome, we have the simple ones, where the certainty of the outcome is very high, over 99%. Now, looking to this to some real world example, a simple system can be your car key. Quite simple device, either it's mechanical or electronic. Still, it's a very simple device. You turn the key and the lock, or you press the button and the car doors unlocks. So you turn the key faster, you press the button faster, car gets unlocked faster. It is not even complicated to understand if you actually break it apart, because it's not with not that it does not require that much mechanical or electronic knowledge. Then we have complicated system, where the certainty of the outcome is around 80%. Complicated system, as an example from real life, is the car in itself. In general, a car is built out of about 30,000 components. It's complicated, but quite easy to actually figure out what will be the outcome when you start the engine with a key. So, or when you press the pedal to the metal. So don't do it. Well, car goes forward faster, and then the outcome, if you press the pedal to the metal, it's a speeding ticket. Well, don't do that again. So just uh, that just as a bad example. So you press the brake pedal, car stops. With some skills, you can even brake. I mean, brake, don't not brake, but take apart the car, and maybe in a few weeks you can even learn each component what it does. And in general, as a general remark, so faster you go, you reach the destination in a shorter period of time. Then we have complicated systems, and where the certainty of the outcome is around 20%. Now, when you take this car on the road, even that you know from where you go and you are doing it every day, it's so. For example, going from home to office, even if you take the exact same road every day and every time, the environment is always different. So there are other cars around that behaves in a various way, different weather. Even you can be in a different mood. So yes, you might reach your office in one point of time, but there is no certainty of that when looking to the variables that comes around. And the last one is actually the house, where there is no certainty of the outcome. Sure, some mathematicians might argue with me here, as the chaos theory is a branch of mathematics focusing on the study of chaos, states of dynamical system whose apparently random states of disorder and irregularities are often governed by deterministic laws that are highly sensitive to initial conditions. So chaos theory is actually an interdisciplinary theory stating that within the apparent randomness of chaotic complex systems, there are underlying patterns, interconnectedness, constant feedback loops, repetition, self-similarity, fractals, and self-organization. So anyway, to summarize it, the certainty of an outcome is zero, as it is not possible to predict the outcome in any meaningful way. So driving the car on the streets of Jakarta, for example, sorry for those in Jakarta, but I guess they know what I'm talking, does not guarantee that you will reach your destination. It is just house there. So for sure, the world is not simple, and also we don't really want to go to chaos. So then let's focus on complicated, which complicated means that there is a limited number of interdependencies, variables are known, it's opposite to simple. So then complex have a greater number of interdependencies, and not all variables are known, it is opposite to predictable. So the world around us actually is in a process of changing by moving from complicated to complex, and all systems around need to be able to tackle with this. So the traditional tool for complicated environment has been the drive for efficiency. Meanwhile, complex means less predictable. When you cannot predict, you need adaptability. So you remember the car ride from your home to office. The way how we all manage every day to reach our office in a complex, continuously changing traffic with very many variables in it is by adapting as we go. So Adaptability is fundamental for success in a complex world. So what does this mean for the telco and IT industry? So the telco and IT converged access digital ecosystem is in the end driven by the users of it, whatever those would be: analytics, applications, business users, consumers. All these users get their services from the exposure layer, where all services are made available to the actual consumers. Then we have actually enablers, and the enablers are then exposed via API. So exposing all the application via API that are built, and then they are creating all these unique services that actually are consumed by the users side. All of this is basically built on top of an infrastructure that have various components like software-defined data center, software-defined access, and then user-defined resources. So all of this is very complex set of services that have also many layers of management and operate such environment. So you have facilities management, maybe, yes, facility management that is taking care of things like cooling, heating, power, etc. There is a hardware management, looking at the server, storage, networking. There is a unified cloud infrastructure for the actual cloud infrastructure management, management and orchestration for the network function applications. And then for all the layers, we have identity and access management to control who can access what and when, telemetry and charging, telemetry to measure what is going on there, and charging that is split in showback and chargeback depending on organization and the scope. Contract management and payments, security management, and in some cases telecommunication especially, we have also lawful interception. Now when you look at this picture from the perspective of the change from complicated to complex, then it's clear that the actual agility that I discussed that is required to tackle this transition and to tackle this complex world, it is not only about software, but is about all layers that are part of this system. So when we talk about cloud native as such, we are indirectly covering all layers that are around it, even without knowing it, because the demand for the adaptability is cascading, starting from the user and goes till the bottom, including hardware and facilities. Now, let's see where we are so in this journey. So telco and IT were very separate domains with different drivers and building using different specialized solutions that had limited or no direct interaction. In the last period, it can be seen clearly that these two worlds are converging. Each world brings some characteristics. Telco have a good track record in quality, standardization, real-time processing, carrier-grade reliability, telco domain competence. Meanwhile, web scales, ITs, comes with the typical IT advantages like virtualization, cloud native, agility, scalability. Now, when combining these two, would ensure the quality, reliability, but also agility to thrive in the transition from complicated to a complex world where agility is the main driver. So what do we mean with cloud and where are we in this transition? Here is the well-known traditional deployment, monolithic, where hardware and software are combined in one big piece. Next steps on the journey is virtualization. Basically, what is done here is virtualization of the hardware. Software comes as a forklift from the monolithic one, moved on top as a virtual environment, and not that difficult and quite fast to achieve. Is this one cloud? Well, depends who you ask, but how I see it is definitely not. So virtualization is not cloud. Virtualization is inferior to cloud. To move from virtualization to cloud and allow actually automatization is required to re-architect the whole solution. You need to break it in smaller pieces based on services that those components provides. And this is the biggest step of them all, as there is no shortcut. Nothing to be done, then re-architect your components, whatever those are. And programmable means that there are well-defined and well-documented APIs. Sure, this level can come in the same time with the previous one, where we call it cloud. Because the demand of the APIs between all components to ensure separation is smaller granularity of the components, it is already there. But very often the APIs are not always well done. For example, the API abstraction is missing, or the APIs are not documented. And this is why programmability comes only once all these requirements are actually met. Now, once we have the right granularity in all components, we have the right APIs, now we can use AI and ML and AI, so machine learning and artificial intelligence, to actually operate and control the whole environment, including the whole digital ecosystem. So we are reaching basically level 4 in an automated model. That means full-time autonomous operation under all operational conditions that could be managed by a human operator. In other words, the system can do all that the human can do, so little or no supervision is actually required. As the ultimate goal actually will be to move towards an intent-driven system where the overall ecosystem is fully automated. Operation materially outperforms skilled human operators. Intent-driven means that an intent is defined and the whole ecosystem will adapt to achieve the desired results free from human intervention. Intent-driven, it's all around us already. For example, using a Google Maps, you are telling where you want to go. The app figure out where you are, and then with no human intervention, will search and find the best routes, and then provide it to you with turn-by-turn instructions, even using augmented reality and overlap the arrows on top of the real world to help you. So as you notice it, first of all, the agility need to be built in all the layers. This is not only about software or only about the cloud infra. This is in all layers. Hardware need to be programmable with well-defined APIs to allow to be controlled as well. And believe it or not, also facilities need to be agile. So the old way of building data centers like a very big brick, we consider they are long gone, and a more modular approach need to be taken there as well. Second, during this journey, the size of the stacks did not change. So if you look at it, all became broken in smaller pieces to be able to address agility, but that created the complexity of the system that now does not make possible anymore for human to control it in an efficient way. That is why the goal to go towards an intent-driven digital ecosystem where actually human intervention should be something that is redundant. That's the only way to be able to benefit from all the capabilities that comes with this cloud native environment. Now, let's imagine a timeline. Because I hear so many times that any application need to run on any infrastructure. Yes, in theoretical it sounds great, but things are not, how I'm saying, are not exactly like in the movies. So let's imagine a timeline where on top we have the applications. We can call them applications, VNF, which is telco name for virtual network functions, CNF, which is basically the same virtual network function, but there is an invented name, which is either somebody calling it container nothing functions, others are calling it cloud native nothing function. So no matter what, it's actually an application. No matter what the naming, the fancy naming it is invented. So in the lower part, we have the infrastructure. And let's imagine that those applications are cars and the infrastructure are roads. Now, this is how car looked at back in that time. And this is how roads look at that time. So gravel roads. Or were okay. Roads were good enough for the cars of that time, but then cars evolved. When cars evolved, the roads need to evolve as well. So we got the better roads. Better cars of today, better roads of today. Future cars of tomorrow, future roads of today. So, and please, I didn't put any flying car because, 30 or 40 years ago, we've been saying that now we will be in a flying cars, and well, look outside, no flying cars around. So, still roads, still cars. So, now looking back, think about taking either this car of today or taking a Formula One car from the present day and try to get best out of it, running it on the roads from the bottom left, which is the gravel. No matter how hard you want, you will not be able to get the best performance out of it. Same in cloud. No matter how hard we try, running a telco application on a traditional IT cloud infra is like driving a modern fast car on a dirt road. So meanwhile applications evolve, the infrastructure need to evolve too. Now let's talk about cloud native. So cloud native as such is a term that actually describes a cumulation of various architecture, technology, and organization patterns that are using the advantages of cloud computing to support various business models in an agile way. While there is no set of guidelines that defines what a cloud native application is, the industry has identified certain common characteristics for cloud native applications, such as auto configuration. It is about the ability to configure the instance and components of the application on demand when anywhere is needed. Auto scaling, auto scaling is about vertical and horizontal scalability on demand to be able to map resource utilization as close as possible with the actual demand with as little as possible waste of resources. I will cover this one in more details later. Auto healing, the applications need to be able to monitor allocated resources all the time so that it can detect and recover from infrastructure and application components failures so that the service that provides is not impacted. Composed of microservices, this is about granularity, decouple the application in smaller components that each provide a clear defined service, better scalability and resiliency and enabler for CI/CD, DevOps, and later on DevSecOps. Being software defined, programmable, very important. It's not only about programmability of the application, but also the programmability of all the components that are part of it. Self-secure, need to comply with the security guidelines, regardless of the infrastructure security. So microservices, as you noticed, is not an architecture pattern which provides many of those characteristics. So it's one of the architecture patterns, but it's not a single descriptive feature. So it is not included in this list as such. Also, the whole cloud native concept is valid for all layers. That is, in the end, a way of working as an enabler for DevOps that in the end is characterized by the needed agility to tackle the complex world. What needs to be done to move towards cloud native? So simpler and smaller applications, that means move towards microservices that allows DevSecOps to happen. Standalone architecture, move towards a business logic only model so that all other services around it can be common uh, and and reused. In the end, the only difference between apps is the actual business logic. Stateless architecture, moving towards using a common data layer, and for sure, each microservices to own the data. No hard-coded values. That means all application and microservices need to have well-defined and documented APIs. Well-defined means that an abstraction layer is required so that business logic is not directly exposed and allow in this way backward compatibility. Sure, it can then easily turn in open interfaces, but this is a business decision and not a technical decision. Able to work on unreliable infrastructure means that it should continuously monitor the resources. When there are resources requested, that is a management activity. Meanwhile, when the application use the runtime to actually work. So that means if some application management system is telling you that you got a certain amount of RAM, for example, does not necessarily mean that you got it. Also, once you got it, does not necessarily mean that it's there forever. So keep checking all the time. I'm telling you that if I'm telling you that I just transfer 1 million euros in your account, I guess that before you go on a shopping spree and buy the whole shop, you will first check your account to see if you really got the money, right? The same applies here. Now let's talk about operational efficiency now. Now, when it comes to cloud native, we should look at the additional side effects of agility, that is operational efficiency. On the x-axis, we have the resource output, and on the y, the service capacity output. We have the dynamic operation efficiency to resource consumed transitioning from one configuration to another. Then we have the steady state resource efficiency for steady state intensity of resource consumption in a particular configuration. And now this is the theory. So now let's see how this goes in practice and what all of this means. We have the minimum resource consumption, which is called smaller x intercept, means basically less resources overhead as long as that goes closer to the axis. Higher slope higher slope of that means that higher resource efficiency. So how more, let's say, abrupt, or how it's called in English. So how more vertical that slope comes, as higher the resource efficiency. More elastic steps, so those stairs, means online capacity can track closer to perfect target capacity. So as more steps you have, as smaller it is better. And then this is the range of the output capacity. You can see it in the left side as an arrow, because the output capacity of your application does not start straight from the bottom, because there is this resources which are used, which are resources overhead, which are used, and then you have the maximum resource consumption is like total resources, the overhead plus the service capacity output. So more elastic steps means online capacity can track the perfect target capacity. Now, let's say this is the actual demand, and then I will go in explaining the levels. They are not all drawn in this graph. So the level 1, which is lifecycle demand, it's a once per week. It's the simplest capacity management strategy, is to engineer the initial deployment with sufficient capacity to serve the peak forecast demand of the applications, useful service lifetime. This minimizes the number of capacity management actions executed, but guarantees that a huge portion of the application capacity will be surplus. So for all or most of the applications, useful service lifetime. Now, level 2, it's seasonal demand. Organization can engineer to peak forecast demand for a few months into the future, review capacity plans regularly, like every few months, and adjust online capacity as needed. Configuring sufficient capacity to only serve demand for a few months into the future rather than for the application's entire lifetime permits less capacity to be held online, which reduces capacity waste compared to level 1, which is lifecycle demand. Now we have level 3, which is like a weekly demand. Making weekly capacity management decisions enable organization to reduce waste online application capacity even more than level 2 seasonal demand, because one can generate forecast next week's demand for more accurately than months into the future. Weekly cycles of capacity decision and fulfillment can be done via a largely manual process, but automation reduces the staff effort and cost associated with each demand planning and fulfillment cycle. And then we have level 4, daily demand. Scheduled daily peak online capacity cycles can be automatically executed to reduce capacity waste compared to level 3, weekly demand. Automation is required for this maturity level because it is too expensive and risky to manually execute twice daily capacity changes. But then we go to the level 5, which is a real-time demand. Rather than relying on regular scheduled daily capacity changes, the organization now can deploy automated scalability capacity management mechanisms to adjust the online capacity near real time, to track with actual patterns of user demand and reduce capacity wastage compared to level 4 daily demand. For example, capacity decision process can reevaluate online application capacity every few minutes and order appropriate capacity change actions when necessary. And that we have the yellow line, which is actually the perfect online capacity, which is the actual demand. And of course, that will be ideal to be able to match that, but the best is to come as close as possible with it. And cloud native with containers, with all these characteristics, actually allows you to come as close as possible to it, with, of course, as part of the overall cloud environment. Now, let's talk about some key takeaways. So, cloud native, so drivers, adaptability, solution for the complex world. VNF, CNF applications, whatever you want to name them, need to operate in a complex, less predictable world. In such a world, adaptability is the key for success. Adaptability here is stated in a wide sense, chasing closely the actual demand, but also faster changes in the product functionalities enabled by modular build. Then we have number 2, which is convergence of telco and IT. from traditional stack to virtualization stack is the typical first step to start legacy application cloudification. Typically, application is only fit to run in a cloud environment when and doing virtualization, basically same and similar application run in a cloud environment. With virtualization, only majority of the cloud environment benefits are not realized. So basically, that's why kind of IT type web scale deployment, truly cloud native, need to be to be executed. Business agility, which absolutely comes automatically with all of this, the rest of agility, requires that the application need to enable new services and revenue streams. So the application architecture must enable everybody to fail fast, learn fast. Programmability and co-creation through open API foster the creation of an ecosystem and building solutions from multiple vendors' components. So applications need to be modular and adaptable to be able to serve new customer segments without lengthy feature development. And then we have the last one, which is operational efficiencies. It's about the pure output input ratio of the application. For example, active subscribers served per allocated vCPU. This needs to be modeled and measured over the whole scaling range required from the application. This is impacted not only by the efficiency of the chosen business logic algorithms and software implementation, but also by the architectural characteristics like the base footprint of the common service of the application. Also, the granularity of available scaling steps impact this as they allow to optimize the resource usage according to requested traffic. Granularity of the scaling steps is directly related to the modularity of the architecture in terms of deployable units. So efficient scalability enables other business models like pay-as-you-go, for example. Now, I guess that's about my presentation. So it's time for some Q&A.
Thank you, Adrian. Thank you very much. Fantastic talk, very comprehensive. I think you gave us a good understanding of what, how things are being designed today, and what the future holds for us. We have a few questions, and thank you to our participants for putting those questions to Adrian. Let's go with the first question then. What is the current situation in the operators' terms of implementing cloud-native architectures, and how far are we from saying that operators have a pure cloud-native architecture in their networks?
Okay, hi everybody. I hope you can hear me.
Welcome.
Nice to be here. So that's in a short answer. So what is the status of operators like CSPs? Is like they are all over the place. Means that from you remember the picture where I've been showing the status of cloudification from the monolithic one till intent driven. So more or less they are all over the place, but again depends of the domain. I mean, some things could be easier move to cloud, especially related to the IT like BSS, OSS, and so on. But other things like cloud, like run, for example, or even core now it's more or less cloudified. They are not, they were not so easy. So that's why in the end, it's depending on the operator, they are all over the place, but they are all in the end, they are all trying to get there. And it is a journey, so it will take some time.
Thank you, Adrian. Thank you very much. All right. What about responsible engineering? You mentioned earlier on about an intent-driven ecosystem where the AI kind of takes over and delivers on what it considers we intended it to deliver. But what would happen if something isn't engineered in a responsible way to be able to have a failover or have the care of the human at its core, if you like, and the AI might misunderstand the human and decide that the human is redundant overall and remove the human?
Okay. Well, how I'm always saying, it doesn't matter. We can try to blame the AI, but I still consider that the only one which can blame is us, because we are the one which we are feeding with the information. If I'm showing a picture of a cat and I'm telling it that it's an elephant, so of course after a while when I show a picture of a cat, it will tell me that it's an elephant. So who fault is this one? So I still consider it that yes. in the end, it's us as humans which we need to, how should I say, to behave also when we implement AI. So we need to continuously monitor what the AI does and to be able to figure out if it does it right or not. Because AI in the end, it's kind of maybe I use a very wrong way. I'm saying it's a guessing game. It's how much it can guess that something is like that, and then it's based on these probabilities decided is one way or another. So it's a guessing game. Again, maybe it's a little bit too harsh term, but that is how it is.
Thank you, Adrian. Thank you very much. We have another question about Nokia, and you're a chief architect at Nokia. How is Nokia transformed to stay competitive in the era of pandemics? Is this new way of working beneficial for a company like Nokia?
Well, I cannot really talk on a Nokia general. I can talk only on my experience. So, is it good or bad? Well, as always, you see, that, like my presentation was, it's about adaptability. So no matter what, we need to adapt and then move on and continue working no matter what are the conditions. So that's what we do now. Is it better or worse? I don't know. There are some positive things, there are some negative things, right? So you know how I'm always saying, we need to make the best out of everything. So yes, we are doing, at least what I can say from my limited area, which I'm interacting. I think things goes pretty well in many aspects.
Thank you. I'm seeing as we're one of our subject today is brain gain. I want to talk a little bit about skills, and specifically, if you were a hiring manager at Nokia, what would be the core values or the core capabilities that you would want from someone who would be wanting to join your team?
Yeah, you know, it's not you cannot know everything. So the key part is like you should be willing to learn, but not like, yeah, I mean, you need somehow to demonstrate that. So the willingness to learn based on your past, and then the second one, it's about how you are as a person, how you fit in the environment where you are expected to work. These are sounds strange, but these are more important than what you know. So that's what I'm saying, at least from my point of view. I appreciate more the way how people are or how they are able to adapt than they are like an encyclopedia in themselves.
Thank you, Adrian. Now, let's go back a little bit to cloud native. Some of the most important steps towards implementing cloud native. If you were to name the top three issues.
So the cloud native, it's a mindset. So number one, it's a mindset change. It's like sounds strange, but it's like a culture. It's not really a technology. So it's a mindset change. You need to understand what does that mean. The second one, I will say, okay, it's a DevOps, because you need to have the loop to have feedback so that you can fix your problems fast and then go back. And so continuous development, continuous improving of your software. And then the third one, I think, which I always consider from technical side, you must start and build from the beginning, from day one, well-defined APIs with a very good abstractization. Sounds like a broken old LP, but you will not believe how much this is like forgotten. Because it's like, yeah, I build an API, here is an API, but then it's exposing the internal of the application, and then basically any change you do, it is automatically exposed outside. So I think these are the three main parts of it.
Well, thank you, Adrian. That was a fantastic talk, and I'm told that you have to leave and go into the other room because you're involved in a panel. So everybody, say a big thank you, a big virtual round of applause to Adrian Peret from Nokia, and thank you very much for joining us.